You should be on page 40 in your notes packet. Today we're going to learn how to solve one-step equations. And they're called one-step equations because it only takes one step, so you would either add or subtract or multiply or divide to solve them. When solving an equation, your goal is to get the variable by itself on one side of the equation. This is called isolating the variable. To get the variable by itself, you must use inverse operations. Inverse operations are the same as opposite operations. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is multiplication. An equation is balanced, which means that both sides are equal. To keep the equation balanced, you must do the same things on both sides of that equation. Let's look at some examples. A says y plus 9 equals negative 31. I notice that my y is on the left side of my equation. My equation's separated into sides based on the equal sign. So I have y plus 9 on the left side and negative 31 on the right. To solve an equation, I need to have my variable by itself. Well, right now, y has a 9 with it. So when I look at what y is doing to 9, I see that it is adding 9. Well, to get rid of the 9, I would need to use the inverse or the opposite of adding 9. Well, the inverse of adding 9 is subtracting 9. I need to do this on both sides of my equation so that I can keep my equation balanced. So I'm going to subtract 9 on both sides. Over here, you'll notice that we have positive 9 minus 9. Well, that makes 0. So if I have y plus 0, it's just y. That means that these cancel each other out and leave me with y. I always need to bring down my equal sign. And then on this side of my equation, I have negative 31 minus 9. Well, when I solve negative 31 minus 9, I get negative 40. So y is equal to negative 40. We can always check our answer to see if it's correct by substituting our answer into our original equation. Well, our original equation said y plus 9 equals negative 31. But my answer was negative 40. So I would plug in negative 40 for y. So instead of y, I would write negative 40, and then I would write the rest of this, which says plus 9 equals negative 31. Well, negative 40 plus positive 9 gives me negative 31. And since I get to an answer that is balanced, which means that it is equal, that means that my answer of negative 40 was correct. Now, I'm going to show you an example of why you would need to always check. So if I had solved this incorrectly, maybe, for example, I had added 9 here. Well, if I did that, first off, you should notice right away that that would be wrong, because if I do 9 plus 9, that's 18. Well, that's not getting y by itself. That's now having a y with an 18 instead of 9. But if you accidentally did this and just canceled them out without checking it, you'd get y equals, and then negative 31 plus 9 would give us negative 22. Well, if I plugged that into my original equation, I would do negative 22 plus 9, and I would say equals negative 31. If I solved negative 22 plus 9, I would get negative 13 equals negative 31. Well, this is not true because these numbers are not equal to each other. So that would tell me that this solution would have been wrong. So when you check your answer, you can see whether your answer was correct or not. Now let's look at part B. Part B says 90 equals negative 15x. I notice that my variable is now on the right side of my equation, and I need to get it by itself. Right now it has a negative 15 with it. You'll notice that there is no sign here. If there's no sign telling you that you're adding, subtracting, multiplying, or dividing, and instead your number is just right next to your variable, that means that this really says negative 15 times x. So to get rid of negative 15, I would need to use the inverse of multiplying by negative 15. Well, the inverse or the opposite of multiplying is dividing. So to get rid of negative 15, I am going to divide by negative 15, and I'm going to show it by writing it as a fraction, and I'm going to divide by negative 15 on both sides of this equation. When I do positive 90 divided by negative 15, I get negative 6. Then I bring down my equal sign. Well, negative 15 over negative 15 cancels because that makes 1, and 1x is the same as just x. So my solution is that negative 6 is equal to x. I can check this by putting it into my original equation, which said 90 equals negative 15x. Well, I would say 90 equals negative 15 times x, but we said that x was negative 6. Well, negative 15 times negative 6 gives me positive 90, which means that my answer of negative 6 is correct. Part C says m minus 11 equals negative 45. For C, I notice that my variable is m, and m is on the left side of my equation, but it has a minus 11 with it. That means I need to do the inverse or the opposite of subtracting 11. The opposite of subtracting 11 is adding 11 on both sides of my equation. Well, on my left side, you'll notice that this is a negative 11. So if I add negative 11 plus positive 11, I get 0. So m plus or minus 0 is still m, so those cancel to leave me with m by itself. On the right side, I'm adding negative 45 plus positive 11. Negative 45 plus positive 11 gives me negative 34. That means that m equals negative 34. I can solve this by putting it in my original equation. So m is negative 34, and I would do negative 34 minus 11 and see if it equals negative 45. Well, if I solve negative 34 minus 11, I get negative 45. So since these two are equal, I know that this answer of negative 34 is correct. Now let's look at D. D says x over 5 equals negative 13. I see that my x is on the left side of the equation and it has a 5 with it. Well, since this is in a fraction form, I know that a fraction bar always tells me to divide. So this really says x divided by 5. Well, to get rid of my 5, I would need to use the inverse of dividing by 5. Well, the inverse or the opposite of dividing by 5 is multiplying by 5. So I'm going to do that on both sides of this equation. These 5s would cancel because a 5 over 5 makes a 1, and 1x is the same as just x. Then I would solve negative 13 times positive 5. Negative 13 times positive 5 gives me negative 65. So my solution here is x equals negative 65. I can check that by putting it back into my original equation. So my original equation said x over 5 equals negative 13. Well, I would plug in negative 65 for x. Well, then I would solve this side, which says negative 65 divided by 5. Well, negative 65 divided by 5 is negative 13. So since I get negative 13 is equal to negative 13, that means that my answer of negative 65 is correct. E says 3/5 x equals negative 18. Well, 3/5 next to x means 3/5 times x. The inverse of multiplying by 3/5 is dividing by 3/5, which I'm going to do on both sides of this equation. These will cancel to leave me with x equals, and then over here I have negative 18 over 3/5. Well, that's like saying negative 18 divided by 3/5. Well, if you remember our rules for dividing with fractions, our rule is multiply by the reciprocal. So that would mean I would keep negative 18 and multiply it by the reciprocal of 3/5. Well, the reciprocal is just this fraction flipped. So the reciprocal is 5/3. Well, when I multiply, I know I should probably put my whole number over 1 and then multiply straight across. Negative 18 times 5 is negative 90. And then 1 times 3 is 3. Well, then I would just divide here, negative 90 divided by 3, and that gives me negative 30. So negative 18 divided by 3/5 is negative 30. That means that x equals negative 30. I can check that by plugging it into my original equation, which said 3/5 x equals negative 18. Well, 3/5 x means 3/5 times x. And since we said x was negative 30, I would do 3/5 times negative 30 and see if I get negative 18. Well, when I solve 3/5 times negative 30, I do get negative 18. So since these are balanced, my answer of negative 30 is correct. For part F, you see that I have negative 4x equals 7/8. Since negative 4 is right next to x, I know that it's being multiplied by x. The inverse of multiplying by negative 4 is dividing by negative 4, which I'm going to do on both sides. These will cancel to leave me with x equals. Well, then I need to solve 7/8 divided by negative 4. Well, I know, again, I would multiply by the reciprocal, so 7/8 would stay the same, and I would multiply it by the reciprocal of negative 4. Well, if I have to flip negative 4, I have to remember that there's technically a 1 under a whole number. So when I flip it, it becomes negative 1/4. Then I can multiply straight across. Well, 7 times negative 1 is negative 7, and 8 times 4 is 32. So that means x is equal to negative 7 over 32. If I check this, I would just do negative 4x equals 7/8. So I would plug in negative 7/32, and I would see if I get 7/8. Well, this is technically over 1. So negative 4 times negative 7 is 28, and 1 over 32 is 32. Well, it doesn't look like I have 7/8, but if I look at this, I can actually simplify 28 over 32. Both of these can be divided by 4. If I do 28 divided by 4, I get 7, and if I do 32 divided by 4, I get 8. So really, I do have 7/8 is equal to 7/8, which means that my solution of negative 7 over 32 is correct. Now let's apply this to some real-world problems. G says, at a restaurant, Mike and his 3 friends decided to divide the bill evenly. If each person paid $13, how much was the bill? Well, the first thing that you have to recognize is that it says Mike and his 3 friends. It does not say 3 friends decided to divide the bill evenly. It says Mike and his 3 friends, which means that there are actually 4 people total who are splitting the bill, not just 3. So if each person paid $13, how much was the bill? Well, 4 people paid $13, and we want to know how much their bill was. Well, when I know that I had the bill split or divided evenly, I know that it was divided into 4 equal pieces. So it started with whatever my bill was, which is X, and I divided it into 4 equal pieces. And when I divided it into 4 equal pieces, each person paid $13. So the equation that can solve this is x over 4 equals 13. Well, since this is a dividing problem, I'm going to use the inverse, which is multiplying by 4 on both sides to get rid of it. These will cancel to leave me with x equals, then 13 times 4 is 52. Well, this means that the total bill was $52. H says last Friday, Trayvon had $29. Over the weekend, he received some money for cleaning the attic. He now has $41. How much did he make for cleaning the attic? Well, if I know that he had $29 and then he received more money, that means that he added to the $29 that he had. So he started with 29 and he added money for cleaning the attic. Since we don't know how much money he added, we're going to put X. We know that once he added that money, he now had a total of $41. So my equation is 29 plus X equals 41. I need to get X by itself, so I need to get rid of this 29. Well, since this 29 is positive, the inverse of that is subtracting 29. So I am going to subtract 29 from both sides of this equation. Well, when I do that, these will cancel and leave me with positive X. And then 41 minus 29 leaves me with 12. So that means that Trayvon earned $12 for cleaning the attic. All right, now I says how many boxes of envelopes can you buy with $12 if they each cost $3? Well, I know that we're buying envelopes that cost $3 and I have 12. So I'm taking 3 and multiplying by however many boxes, so 3 times X, and I'm getting a total of $12. Well, when I multiply 3 times X, the inverse of that is dividing by 3. So I'm going to divide by 3 on both sides. These 3's will cancel to leave me with X equals, and then 12 divided by 3 is 4. So that means he can buy 4 boxes of envelopes.